Okay, welcome to Angle Additions. Now this one says which of the following statements are true, and you'll notice, of course, I don't have really any options for you, but what I'm going to do is I'm going to try and create several options for y'all. So check this out. What do we know? We know that whenever two lines intersect, their opposite or their vertical angles are congruent. All right, their vertical angles are congruent. Now in this case, we can actually create vertical angles through sections or combinations of angles. Let me demonstrate. What if I took my nice purple color here and I were to highlight potentially, let's say, oh, I don't know. Yeah, why not? These two lines right here. Well, notice I have this gigantic angle right here, but it encompasses two parts. I also have this gigantic angle right here, which also encompasses two parts. Now, notice, I'm going to use different colors here. This top part and also this bottom part are not congruent. In fact, let me use three arcs to show that it's distinctly different. So how could I create some sort of congruency statement here? Well, in the orange, we see that this angle right here is CKA. So we could say angle CKA plus, and in this kind of nice neon green here, we have angle AKI, angle AKI. And what are we going to set that equal to or congruent to? Well, we're going to say that that is congruent to angle and this whole angle right here, which is clearly HKJ. Just squeezing it in barely. Now, that's not the only set we could have here. I haven't really counted these up. My guess is we could have 6 different combinations. What if we took this nice orange color here? Or you know what? Here, I got an idea. Okay, my brilliant idea was just to start fresh. Okay, let's take my nice purple color here, and let's actually choose some different lines this time. Oh, I don't know. Let's do let's do this. Okay. What do we have here? Yeah, we've kind of rotated the lines that we chose by just a little bit, and notice now here are what our gigantic angles look like. And in fact, let me switch it up. This time, let's pick our two smaller angles on the right. And I'd like for you to pause the video right about now and see if you could come up with a congruency statement where you're adding those two angles on the right. Pause it now. 3, 2, 1. Well, what would that look like? Well, we know that this angle right here is HKB. So angle HKB. And we could say, you know what, plus, go back to our nice little neon green here, this angle IKH, angle IKH, is congruent to, well, of course, the combination of those two vertical angles is that giant purple angle, let's see if I can squeeze it in, AKJ. AKJ. So notice, guys, we could continuously like pick and choose different angles, but I really want y'all to draw this out whenever you attempt to solve these problems on the next section. All right? Draw them out, and then that's going to help you out. All right, let's move on. Okay, let's take a look at example 2. Now, what do we know about example 2? Well, it's this triangle, but it peculiarly has this angle on the outside. Now, if you will recall, that is our exterior angle. And we actually have a pretty cool rule here. So for some form of angle addition, like congruency statement, we actually have something called the exterior angle theorem. Exterior angle theorem. And by the way, guys, this should be review. You should know this at this point. But what does it say? Well, the exterior angle theorem says that our two remote interior angles, so this one, and this one, they need to add up to be our exterior angle. Okay, so what would this look like in practice? Well, we could say that we have angle ABD plus angle, this one right here, BAD, is congruent to our exterior angle, which in this case is angle ADC. Angle ADC. DC. So remember, guys, any two interior angles that don't touch the exterior angle, they can add up to that, and it gives us a nice little shortcut pretty frequently. All right, guys, we got one final example. Let's go check it out. Okay, let's take a look at example 3. Now, what do we know about this guy? Well, we know that it is overall going to add up to 90 degrees. Anytime we see that perpendicular line, or how else do they like to tell us? You know, they like to say this. They like to say that AB is in fact perpendicular. Remember that upside down T from earlier, perpendicular to BC. Okay, well notice, here's my question to you. How many angles can you count? Well, hopefully you count 1, hopefully you count 2, and hopefully you count 3. And all nice little just shades of transitioning from purple to red. So what can we say here? Well, of course we could say this. Angle ABD plus, switching to this nice little tropical punch color, angle DBE plus, and then of course our last one down here in this nice red, we could say plus angle EBC, all adds up to, well, 90 degrees. Okay? Question, could we create combinations of angles? Potentially. What if I wanted to do this in orange? What if I wanted to combine two angles? What if I want to say, you know what, I just want to look at this angle as a whole? Well, check it out. I could say angle A to B to E. I could say angle ABE, you know, old honest Abe, plus our remaining angle. Notice it's still this remaining angle here in red, plus angle EBC is congruent to or equal to, and of course, 90 degrees. There's one other combination here. If you would like to search for it, I leave you to find it. But these are various ways we could say angle addition congruency statements. Okay, let's move on to our final video.